Good morning, everyone, and welcome to our live coverage of the latest mission from Cape Canaveral Space Force Station. I'm Will Robinson-Smith. I'll be providing our commentary for the duration of this coverage. We are broadcasting, as we always do, from the Spaceflight Now News Bureau here at NASA's Kennedy Space Center. We are coming on slightly later than initially intended. It is a soggy day, I could say most generously, here on Florida's Space Coast, as what is now Hurricane Milton continues to make its way towards Florida. Latest update from the National Hurricane Center is the storm has increased in strength and is now tracking as a Category 4 major hurricane. Rain is beginning to fall, or has been falling, here at the KSC press site as well as out at Cape Canaveral Space Force Station. However, as of the last 10 minutes or so ago, as you can see, the rocket is standing tall at Space Launch Complex 40, Slick 40 over at the Cape. According to the European Space Agency, whose mission this is, they are currently go for launch after passing through the L-2 hour weather check, but note, and I will quote them here, there will be additional weather checks prior to liftoff. We are joined by our usual crew today. Stephen Young is running the technical operations of the broadcast this morning. Our Adam Bernstein is out preparing to track the rocket and has been a trooper, getting our camera set up safely in the rain and making sure that they and he are both protected, but that we're still able to bring you views of the rocket. This particular angle coming to us from our friend Chuck and Jen Briggs over on the Cape side. Our friend Pete Carsons with Max Q Productions will also be joining us for launch coverage a little bit later on in the broadcast. If you're not following our photography team, you can find them over on X. Their handles are ABurnNYC for Adam, MD Kane Jr. for Michael. And while you're there, be sure to follow Spaceflight Now simply at Spaceflight Now. We are also on Threads and Facebook if you yourself are not on Twitter, now X. As we're getting things going, want to thank the more than 1,000 of you who are joining with us live. If you haven't already, we'd certainly appreciate it if you could hit that like button for us, allow some more folks to find their way into this live launch coverage. Also want to thank our moderator in the live chat, Callistia Lee. We'll also keep our eyes out for any other mods who happen to be joining us later on this morning. Here at Spaceflight Now, we're powered by a very wonderful channel member community, so thanks to folks like Mark Potachnik, Patty Chichil, Sulfur for Lunch, M. Teresa, Greg Williams, and many others. Channel membership comes with a number of perks, including discounts at our online shop, that is shop.spaceflightnow.com, access to member-only videos here on YouTube, and of course the ability to watch all of our launch liftoff moments from here in Florida in 4K. Good morning to Meg McElroy and Mark Otto, others as they're starting to cruise on in here this morning. Last but not least, if you have a comment or question about this Hera mission or general happenings going on in the world of space, you can use the YouTube Super Chat feature. Not only will he be giving us some interesting things to talk about as we progress through the countdown, but you'll also be supporting what we do here at Spaceflight Now, and that is always very much appreciated. As you can see with the countdown clock on the upper right-hand corner of your screen, we are currently T-minus 1 hour, 9 minutes, 12 seconds and counting to the planned liftoff with an instantaneous launch window of the Hera mission for the European Space Agency. Being that this is a planetary mission, this will be an instantaneous launch opportunity today and every day during their launch attempts, if they are unable to launch today. Weather coming into this opportunity was quite dismal. Just a 15% chance of favorable weather at liftoff, according to the 45th Weather Squadron. Again, Category 4 Hurricane Milton is taking straight aim for Central Florida. And so a lot of preparations are currently being made. A lot of impacts already starting to be felt, including on the space front. Later this week, the important Europa Clipper mission to Jupiter's ocean moon of Europa was scheduled to roll out of the pad. You can see in this live view angle from our cameras here at the press site of Launch Complex 39A here. A little hard to make out given the rain falling right now, but on the far right hand side of your screen you can still see a bit of the outline of the hangar there at Launch Complex 39A. That's where the Europa Clipper spacecraft itself is currently hanging on and hanging out, bunkering down until the hurricane passes. Again, Milton is currently tracking to make a pretty much perpendicular sweep across the state of Florida from the Tampa area, cruising on through to our side of the state. You can see here a satellite view briefly of that. We'll come back. Here's an image from GOES east of the cloud cover right now. Circle obviously indicating the Cape area. Weather has been the sticking point throughout the progression towards this mission being able to launch today. This is not their only launch opportunity, though they do have a limited planetary window in order to launch this mission, which we'll talk more about the mission specifically in just a moment here. But they have until October 27th in which to make this rocket fly to begin the quest of this Hera spacecraft as it begins its journey out towards the binary asteroid system of Didymos and its little satellite moon called Dimorphous. If those names ring a bell, you may recall that NASA's DART mission, or the Double Asteroid Redirection Test, made its journey out to have a very close encounter, if you will, with Dimorphous. In fact, direct impact, a successful beginning of this pair of missions, proving that a kinetic impactor can alter the trajectory of an asteroid. An important skill to develop for the whole of our planet Earth here. Currently, there are no known asteroids that are on a direct collision course that could have a catastrophic impact if they were to land on Earth, but the idea behind the combo DART Hera mission is, should one be discovered, that we can send a spacecraft out with enough advanced warning to give it enough of a nudge that we can protect our planet. So with DART making its impact in just about 2 years ago, almost exactly in late September of 2022, now it's Hera's turn. This spacecraft will make its voyage out to the binary asteroid system, and as some of the folks who have been overseeing the Hera mission have described it, it's almost like it's going back to the scene of the crime to examine the impact left by the DART spacecraft. We had the opportunity to talk with a number of folks in the lead up to this mission here. I want to play a bit of sound for you now. This is the project scientist with the European Space Agency and the Hera mission, Mikhail Kupers. Had the opportunity to talk with him yesterday in the run-up to launch, and so here's part of our interview where he talks about the science of the Hera mission even though this mission originally was not born of the science department and is more of a technology demonstration, if you will. But there's still plenty of science to be learned from this. So again, here's Mikhail about the science of Hera.
Yes, so the main points of Hera are as a planetary defense mission. One is to measure the mass of Dimorphous, the mass of the satellite, to understand how efficient the dart impact was in terms of the momentum that is transferred. Another point is we have here the unique opportunity with Hera that we will see the outcome of an impact where we know exactly what has impacted. So we know exactly the mass composition, velocity of dart. While we have many craters on asteroids or the moon or other bodies, it's a unique case that we know what has impact, and then looking at the outcome will improve our understanding of the cratering process.
We'll draw your attention to some of those last images you saw in what was labeled an ESA animation. As you were seeing the images of DART and that view that was getting closer and closer, those were actually real pictures that were being sent down in practically real time from the DART spacecraft using its Draco cameras that were on board. Currently T-minus 1 hour, 2 minutes, 34 seconds and counting. Taking a step back here, as folks are often interested in the graphical representation of a mission in addition to the meat and potatoes itself. Here are the two primary mission patches designs for the Hera mission. The one on the left is from the European Space Agency, the main Hera mission patch. The one on the right is from SpaceX. In both, you can see, of course, the representation of the binary asteroid system. And you'll note there are a couple of other graphical representations of some additional spacecraft that are along for the ride. In fact, this is the first time that the European Space Agency is bringing aboard a couple of CubeSats as ride shares for this. And they're not just hitching a ride for no reason. They're both playing key roles in the Hera mission. They are named Milani and Juventus. They'll be deployed not exactly at the same time, about 2 or so weeks apart, both with key roles in the Hera mission once deployed. There are actually cameras that are on board the Hera spacecraft that will be watching their separation from the vehicle. And so we should see some pretty nifty separation images once those CubeSats are on their way and begin their own distinct missions. These CubeSats are called 6U CubeSats, or 6 units. You can think of them this way. They're about the size of a shoebox, but they each have a lot of technology packed within them. Milani is going to be propelled using a cold gas propulsion system. It includes star trackers for navigation, a laser altimeter, and a visible light camera. Meanwhile, the Juventus CubeSat, which is from the company GomSpace, it has 3 primary objectives. 1, to determine the gravity field of Dimorphous. Number 2, to determine the interior structure of Dimorphous. And 3, to examine the surface properties of the satellite asteroid. Once both of their missions are done and dusted, if you'll pardon the pun there, they are designed to land on Dimorphous. However, the benchmark of success for these 2 CubeSats is not predicated on having a successful landing on Dimorphous. That is more or less an additional objective once they've reached their end of their planned operational life. The mission is set to last about 6 months, as it is currently designed. There are some discussions about opportunities for an extension once the primary objectives of the Hera mission have been completed. So we'll wait to see in 2027 what they decide to do. Currently T-minus 58 minutes, 30 seconds and counting. When this mission is able to launch, potentially in the next 58 minutes, if all remains on track as ESA and SpaceX hope it will be. And actually, before I go to this animation, I want to show you all, we do have an update from the project manager, Ian, who you'll hear from a little bit later on. He reports at T-minus 1 hour and 2 minutes that all systems are go, that weather is improving, and, well, in his post he says that Falcon 9 fueling has started. However, we know that the fueling process will not actually start until about T-minus 38 minutes is when they'll take that final pull to confirm that they are good to start fueling, and then the fueling of the Falcon 9 will actually begin at T-minus 35 minutes. We'll talk more about that in just a second. Taking a look at this mission animation, though, you can see once the Falcon 9 launches, they will actually not be recovering that first stage, which is why see there are no landing legs, there are no hypersonic grid fins out there. See the deployment sequence of the solar panels on the Hera spacecraft. There are a couple of days of checkouts before this spacecraft really begins its main journey out to the binary asteroid system of Didymos and Dimorphous. It'll perform a Mars flyby swing, though, on its way out into a survey of one of the Martian moons, which you'll hear a little bit more about in a few minutes when we get further into the broadcast. And then when it arrives, of course, it's go time, and there's lots of science and work to do once it does arrive out there at that binary asteroid system. Here's a timeline representation of that path out to Didymos and Dimorphous. As you can see, it'll perform the Earth escape and later this month, and then its first deep space maneuver coming up in November. It'll swing out to make its Mars flyby in March of 2025, and you can see the orbit of Didymos there. Should be making its approach around 2026, and then begin the true rendezvous 2 years from now in October of 2026. Lots of work that needs to happen in between now and then, and obviously it'll be quite the journey to make it out there. And if we can even go to video number 3, learn a little bit more about the Mars flyby and the reasoning for that maneuver and what they're going to be doing as a part of this Mars flyby swing. So once again, here is part of our conversation with Mikhail about the Mars flyby swing.
Yes, I mean the highlight of the cruise phase is the Mars flyby. So the Mars swingby to get to Didymos, where Mars will be used for calibration, but we also will arrange for a close flyby of Deimos, one of the moons of Mars, and there we will get it from the not Mars-facing side, which is not very much explored so far. So we also hope some scientific insight from that.
Currently T-minus 52 minutes, 46 seconds and counting. As we were discussing a moment ago, the weather, according to the project manager, Ian, is improving. And as you can see from these live views looking out at the pad, you can actually see the rocket now from the vantage point of the KSC press site. So certainly the best views of the rocket that we've been able to see from Kennedy Space Center so far this morning. So from our vantage point, it definitely does appear to be improving, and hopefully that will continue as they get closer to liftoff and need to start fueling the rocket. Currently T-minus 15 minutes, 48 seconds and counting. Since we do have an expectation from the project manager that the fueling of the Falcon 9 is going to be moving forward soon, let's go ahead and talk about the countdown timeline for this mission and let you know what we're anticipating as the countdown progresses. T-minus 38 minutes is nominally when the SpaceX launch director will take the poll electronically to assess the readiness to proceed into launch. Following that, fueling will begin at T-minus 35 minutes with a pair of events, of course, the loading of RP-1 or rocket-grade kerosene on the Falcon 9's first and second stages. At the same time, liquid oxygen will start flowing onto the Falcon 9's first stage. T-minus 30. It's the point at which they'll start loading cryogenic helium into the pressure vessels of the Falcon 9's first stage. The helium is important because it's used to pressurize the main propellant tanks during flight. The same will happen about 4 minutes later on the second stage. T-minus 23 minutes, the Second stage RP1 tank is full. T-minus 20 minutes and 50 seconds, the strong back chill down process begins. We'll see that visually as the so-called big vent at about T-minus 20 minutes and 20 seconds. But they're chilling the feed lines prior to second stage liquid oxygen loading, which is set to begin at about T-minus 16 minutes. T-minus 7 minutes, the chill down of the 9 Merlin engines gets underway. That process involves flowing a small amount of liquid oxygen through the plumbing and turbo pumps. It helps protect the engines from the risk of thermal shock or damage during the startup sequence. About 6 minutes out, the first stage kerosene tank is full. And at T-minus 4.5 minutes, the strong back retract sequence begins. It starts with the clamp arms underneath the payload fairings opening up, and then the transporter erector of the strong back will recline about 1.5 degrees away from the Falcon 9 rocket. It stays in that position until liftoff, at which point it pulls back in a much more rapid fashion to clear the way for the vertical climb of the Falcon 9. About 3 minutes before liftoff, the first stage liquid oxygen tank is full. T-minus 2 minutes, second stage LOX load completes, at which point the Falcon 9 is fully loaded with 1 million pounds of propellant. In the final 60 seconds, control of the countdown is handed over from the ground sequencer to the Falcon 9's onboard flight computers. The propellant tanks are brought up to flight pressure. Both of those events will be summed up with the call out that the Falcon 9 is in startup. T-minus 45 seconds, the SpaceX launch director will give their go for launch. The engine ignition command will be issued at T-minus 3 seconds. And if all 9 Merlin engines are healthy and ignite, the flight computer will give the command for the hold down clamps to release the bird for a T0 liftoff, coming up at 10:52 a.m. Eastern, 14:52 UTC. And once again, for those who were not with us at the start of our broadcast, this is an instantaneous launch window. So if for whatever reason they are unable to hit that target, they will have to pivot to a backup opportunity, which, broadly speaking, they technically have a backup launch opportunity tomorrow, Tuesday, October 8th at 10:46 a.m. Eastern. Tuesday will also be another day closer to bringing Hurricane Milton to landfall in Florida. So yesterday, the 45th Weather Squadron forecast that launch opportunity on Tuesday was a slightly better weather outlook than today. However, still certainly not ideal. If the launch were unable to happen today, of course, there would be a new launch weather forecast issued with updated forecast data. Also worth noting that given the Space Center is set to shut down ahead of the hurricane arriving, that tomorrow may not actually be a tenable opportunity for the launch. The gates will be closed to non-essential personnel, so there's a lot of work happening today and, well, for the most part today, really, to prepare for the upcoming hurricane's landfall and the impacts here on Florida's Space Coast. Currently T-minus 45 minutes and counting. now currently T-minus 44 minutes, 1 second and counting. In the run-up to this mission, we had the opportunity to sit down with the Hera project manager, Ian Carnelli, talk about the history of the Hera mission, his role in it. He's spent about 18 years of his life trying to get this mission going, so it's quite an emotional time for him and the team that he helps lead. The fact that they are here on the pad and now just potentially 43.5 minutes away from liftoff. One of the things we talked about, in addition to the meat and potatoes of the mission itself and some of its objectives, were how the Falcon 9 rocket was chosen as the vehicle that will begin the journey for Hera. As we mentioned, the rocket is flying in an expendable configuration, so a little hard to see from this vantage point, but there are no landing legs, there are no hypersonic grid fins, or any of the items that are usually seen on the Falcon 9 that would help it land safely on either the drone ship or back here at landing zone 1. So in this part of our conversation, we talked about the use of the Falcon 9 rocket and what it will afford the Hera mission as well.
So initially when we were planning to launch before DART, we could have done it with a much lower much lower energy, so we could use a Soyuz launcher from the French Guiana, from Kourou. When we missed that opportunity, it was already clear that we could not make it with a Soyuz anymore. So when we presented the mission in 2019, it was clear that we needed an Ariane 6 class, so our medium launch vehicle. So at the time we were baselining Ariane 6. And then, some delays happened, and customers started to align, and the queue started to be a bit longer. And that's when we were placing the contract with our prime contractor, OHB, in Germany. And basically, it's when we were writing the statement of work. There's a whole process in ESA before you can submit it to industry, and there was a member, actually the chairman of the board, who asked, who read in our document that the baseline launcher was Ariane 6.2 and the backup launcher was Ariane 6.4. Mm-hmm. And he said, "Wait a minute, it's the same launcher, you know." And I say, "Well, we know, but we're not allowed to go with non-European and so on and so forth." And he said, no, I think this is too risky. You should put Falcon 9 as a real backup if something happens. And so that's when basically we got probably one of the biggest contributions from outside the project to Hera, because from day one, industry had a requirement to be compatible with Falcon. Mm. And when things turned out that to confirm that the Ariane 6 would not be available for us as first customer, and we had then the only way to launch within this strict launch window was to go with a non-European launcher, and Falcon 9 was available. Then basically was no additional work for us. Everything had been worked out. All the analyses that were required were already worked out. So I'm most grateful to this colleague who pushed us to be compatible with Falcon 9 from the very first day.
And our thanks again to Ian for spending a good amount of time with us last week as we were talking about the Hera mission coming up, potentially set to launch in 39 minutes, 37 seconds. At this point, we're just a little more than a minute away from the nominal point when the SpaceX launch director will take that electronic poll for the start of prop load, set to begin at T-minus 35 minutes. We'll talk a little bit more about the booster that's supporting this mission for its final flight today, B-1061, going for mission number 23, which will temporarily make it the flight leader for SpaceX, currently tied with another one of its boosters, which is, as I look at my notes, B-1067, which also currently has 22 missions to its name. Taking a look at the wide view here, you can see it's still quite cloudy from our vantage point here at the press site. However, of course, meteorologists are keeping a very close eye on how the weather is trending, not just what it looks like right this very moment. So, unless something has changed in the next couple of minutes, fueling set to begin 3 minutes from now. Currently T-minus 36 minutes, 6 seconds and counting. First off, I want to thank the more than 2,500 of you who are watching with us live. If you haven't already, certainly appreciate it if you could hit that like button for us. Allow some more folks to find their way into this live coverage. That would be very much appreciated. Now currently T-minus 34 minutes, 46 seconds and counting.
project rep. Project support.
Project support, go.
S-track.
S-track, go.
Scheduling.
Scheduling, go.
Okay, this concludes the roll call for Hera. ESOC is go for launch of the Hera mission.
And some great news there. Looking live right now in ESOC. The operations part of the Hera missions is go for launch from the spacecraft perspective. And we also have word from SpaceX that prop load on the Falcon 9 is also underway. Coming up, the next milestone will be the loading of just listening into some words from ESA. The next milestone is coming up in just a couple minutes at the T-minus 30-minute mark, where cryogenic helium will be loaded onto the pressure vessels on the Falcon 9's first stage. These will help to pressurize the main propellant tanks during flight. Same will happen on the second stage a couple minutes after that. Taking a look at our live chat, want to thank Donna Hayes for gifting 5 Spaceflight Now memberships. Really appreciate that. To our 5 News channel members, welcome aboard. We're glad to have you with us. Be sure to thank Donna in the live chat if you haven't already. You're seeing some of the currently T-minus 29 minutes, 33 seconds and counting. While the Falcon 9 first stage will not be recovered today, SpaceX will, I believe, endeavor to recover the payload fairings on this flight. Fairings splashed down in the ocean waters under this port of parachutes. SpaceX saves about $6 million per recovery effort, so it's an important part of their business model to be able to recover these fairings whenever possible. Here's an image of what the recovery process looks like as they're being brought aboard one of their recovery vessels. As of their most recent mission, here's a look at where SpaceX stands on launches this year with their Falcon fleet. Currently T-minus 27 minutes, 44 seconds and counting. You can tell visibility has once again dropped as from the KSC Press Center vantage point, you can just barely make out the bottom of the, looks like the crew access tower there in the center of your screen, just above the tree line. Is the wide shot here that we have. Taking a slightly closer look, you can see, yeah, that there's the crew access tower there in the heart of your screen. You could just barely make out the lightning protection towers, aided by the fact that they've got those blinking white lights at the top, so you'll see them almost sparkle in this vantage point. Now currently T-minus 26 minutes, 45 seconds and counting. We're coming upon the point of cryogenic helium being loaded onto the storage tanks on the Falcon 9's second stage. Currently T-minus 23 minutes, 15 seconds and counting. In just a few minutes, the strong back chill down process is set to begin. We'll see that visually represented by the so-called big vent. Now T-minus 20 minutes and counting. The so-called big vent now in full swing there at the pad. Again, this is the process of chilling down the feed lines prior to second stage liquid oxygen load. So far, fueling remains on track for an on-time departure of the Falcon 9 rocket. Of course, weather is still being closely watched and will be up until the final decision point is made. Now currently T-minus 17 minutes, 17 seconds and counting. Got about 30, a little more than 30 seconds left on this venting process before SpaceX pivots to loading liquid oxygen on the Falcon 9's second stage. Currently T-minus 15 minutes, 35 seconds and counting. I want to thank the more than 5,200 of you who are watching with us live. If you haven't already, we'd certainly appreciate it if you could hit that like button for us and allow some more folks to find their way into this live launch coverage. It's certainly appreciated. I also want to thank a few folks for your support as well here in the live chat. Our thanks to T-Bon for a $2 super chat saying, bought a front row seat. Thanks for all you do. I hope you have a good time watching the launch, hopefully coming up in just about 15 minutes. Patty Chichil's marking 3 months as a channel member at the pad leader level, saying Spaceflight now in the mods, thank you. Best coverage and channel. It's very kind for you to say. Thanks as well to Psychonaut69 for gifting a Spaceflight Now membership and a hearty welcome aboard to our newest channel member. Be sure to thank Psychonaut in the live chat if you haven't already. And a thanks to Super Tech Boy, one of our other channel members, for a $2 super chat going to our coffee fund. Much appreciated. Assuming that the weather cooperates in the next 15 minutes and this SpaceX Falcon 9 is able to fly, we have a number more folks with us now than we did at the start of the broadcast. So want to give you another look at the science that the Hera mission is going to undertake. While this mission was derived not from the science department of the European Space Agency, there is a lot of important science that they are going to be gathering once they reach this binary asteroid system. So this is Mikhail Kupers, the project scientist for the Hera mission from the European Space Agency. Just had a minor audio hitch. Once again, this is Mikhail Kupers, the project scientist for the Hera mission from the European Space Agency.
Yes, so the main points of Hera are as a planetary defense mission. One is to measure the mass of Dimorphous, the mass of the satellite, to understand how efficient the dart impact was in terms of the momentum that is transferred. Another point is we have here the unique opportunity with Hera that we will see the outcome of an impact where we know exactly what has impacted. So we know exactly the mass composition, velocity of dart, while we have many craters on asteroids or the moon or other bodies. It's a unique case that we know what has impact, and then looking at the outcome will improve our understanding of the cratering process.
And again, the goal with the Hera mission as the follow-along to DART is to examine the impacts of the DART mission, which struck the asteroid Dimorphous, which is the satellite asteroid of Didymos. Back when that strike from the DART spacecraft happened in September of 2022, they were able to shorten the orbital period of Dimorphous around Didymos by about 32 minutes. This is an important demonstration showing that the kinetic energy type of, or a kinetic deflector type of response to a potentially Earth-threatening asteroid is possible given enough heads up and notice that we can take steps to protect our planet Earth here from potentially following the same fate of the dinosaurs. Hera will also have a couple of CubeSats that are hitching a ride on board. Those are called Milani and Juventus, which will have a suite of different instruments designed to further study Dimorphous, from its surface composition to using a radar to better understand the core of Dimorphous. And that'll help researchers better understand more about how binary asteroid systems form. There are some standing theories, but of course, the best way to know for sure is to actually make the approach. Taking a look at the pad here, as SpaceX is giving some overview of the Falcon 9, we'll go ahead and talk about the vehicle here. Taking a look at the interior of the payload fairings. This is the Hera spacecraft prior to encapsulation. Fairings are 13.1 meters or 43 feet tall and 5.2 meters or 17.1 feet in diameter. There is one Merlin engine called the Merlin vacuum engine you see here. Produces more than 220,500 pounds of thrust. On this mission, there will be 2 burns of that upper stage prior to the deployment of the Hera satellite. One of the reasons why the Hera mission was allowed to proceed, even though the Falcon fleet has not been cleared for launch by the FAA, is because they are not performing a deorbit burn with this mission. We'll go to in a so-called junkyard orbit. The first stage booster, tail number B1061. And let's listen to a status update.
Ready for launch as we are just beyond T-minus 9 minutes to liftoff. The Falcon 9 team reported on console at T-minus 2 hours and 15 minutes. They began their final checks of the launch vehicle and ground systems. We did a final check out of the flight termination system. That was at T-minus 1 hour and 45 minutes. We then had the Falcon 9 team complete their data review of first and second stage propellant checkouts, as well as the avionics team and the guidance, nav, and control team, and they did all their final data reviews at T-minus 1 hour. At that point, the chief engineer conducted a technical readiness poll, and everything was go to continue. We've also completed at T-minus 38 minutes the poll to proceed with propellant load and launch, and most recently, you might have heard over the countdown net, the spacecraft has gone on internal power at T-minus 18 minutes and 30 seconds. Now, currently, the team at Cape Canaveral Space Force Station, they are loading propellant. That began on time at T-minus 35 minutes when our launch auto sequence began. We're loading 2 propellants on Falcon 9 today, a fuel and an oxidizer. Now for Falcon 9, our fuel is a refined form of kerosene known as RP1. To burn that fuel, we need a source of oxygen, which we call the oxidizer. Now most burning that you're familiar with on Earth uses oxygen that makes up about 21% of the air you breathe. But in space, there's no atmosphere to provide oxygen or other oxygen-bearing molecules, so rockets need to carry their own. Now, Falcon 9's oxidizer is super chilled liquid oxygen, what we call densified LOX. Now, the liquid oxygen is chilled well below its boiling point. That allows its density to be increased, and that in turn allows us to load more into the first and second stage LOX tanks. And that's an important advantage for missions like today's, where we need as much propellant as we can carry to get to the required interplanetary transfer orbit. Now, currently on the Falcon 9, you see on your screens, fuel loading is complete on the second stage. We're continuing on the first stage up until about T-minus 6 minutes when fuel loading will wrap up on that stage. And we are loading liquid oxygen onto both the first and second stages right now. In addition to its propellants, Falcon 9 also needs an ignition source to start burning that fuel and oxidizer. And for that, we use a liquid called T-TEB.
Stage 1, RP1 load is complete.
And there we hear, we're on time. Fuel load on the first stage is complete. I mentioned T-TEB. That's an acronym for a mouthful called triethyl aluminum and triethyl borane. Now, when we ignite the engines, we first flow liquid oxygen and T-TEB into the gas generator in the main combustion chambers. The T-TEB will burst into flames in the presence of the oxygen. So once we have that ignition, the RP1 kerosene fuel is introduced and the Merlin engine goes to full power. And at liftoff, Falcon 9's 2 stages that you can see next to the strongback, they will combine to hold over 1.1 million pounds of the fuel and oxidizer propellants. Now, to provide maximum performance for the Hera mission, Booster 1061 will use all of its propellant. We won't save any for the landing of the first stage. On the weather front, you can see on the screen, it's cloudy, it's been a little rainy. We started the day with a 50% probability of violating launch weather constraints. But the good news is that the weather officer forecasts that we should be go 5 minutes from now. Mostly we've been watching thick clouds, make sure they're not too cold, where you might have triggered lightning. The good news is the clouds are warm, everything looks just pretty much gloomy, a little rainy.
Tanks are pressing
with
for
that,
strong back retract.
You hear the tanks are pressing, we're getting ready for strong back retract. So inside T-minus 5 minutes, all systems are go for launch from Space Launch Complex 40 in Florida. So Jesse, let's head back and watch the last of the countdown.
And a good update from John Insprucker from SpaceX. As you heard, we are within 4.5 minutes from liftoff. What we wanted to hear was really that key update about the weather, which sounds like it is trending in the right direction, that the clouds that the Falcon 9 would be flying through are warm, not cold, which is what are necessary for a safe flight of the Falcon 9 rocket, and of course to keep the important Hera spacecraft safe. Just beneath the payload fairings, you can see the clamp arms of the Falcon 9 opening up. Then the transporter erector, which is now just to the right of the rocket from this camera vantage point, will recline about 1.5 degrees away from the vehicle. It stays in that position until liftoff. Then it pulls back in a much more rapid fashion to clear the way for the vertical climb of the Falcon 9. Of course, both SpaceX and the European Space Agency very eager to see this Falcon 9 take off in the next 3.5 minutes. While they do have a planetary window that lasts until October 27th, they, don't want to have to deal with the hurricane any more than they already have been, and B, there's a 48-hour stand down between the Hera mission and the upcoming Europa Clipper launch on a Falcon Heavy from Pad 39A. So if this mission were to have to stand down today and the launch were to slide to the right, there would need to be that 48-hour pocket of time between Falcon 9 and the Falcon Heavy launches. It was an agreement reached between ESA and NASA. Do have a call that Stage 1 LOX load is complete. Just a quick note about the countdown clocks you see here on your screen. The top right-hand corner is in real time. What you're seeing coming in from SpaceX is on a slight delay. So we'll be making our call-outs, of course, in real time. Do have confirmation stage 2 LOX load is complete. The Falcon 9 is now fully loaded with 1 million pounds of propellant. What you're seeing here are the ground gas closeouts. As John Innsbrucker mentioned, a gloomy day, but the weather trending in the right direction in a way that, according to SpaceX, would support a launch in now less than a minute and a half. We'll come back to our live chat on the other side of liftoff, but since we are this close to launch, we're going to go ahead and keep our focus on the rocket right now in these crucial minute 15 seconds. Our photographers have all their cameras trained on the Falcon 9 rocket right now. This view from our friends Chuck and Jen Briggs with C&J Images. Now less than a minute to liftoff. Should be hearing the call for go for launch in the next few seconds. Let's listen in.
Falcon 9 is in startup.
With that call out, the Falcon computers are running the final sequence for launch. First and second stage tanks are beginning final pressurization for launch. All systems are go. Let's listen in to terminal count.
LD, go for launch.
And with that final go for launch, we are now less than 30 seconds away from the launch of this Falcon 9 with the Hera mission on board. 20 seconds. And here we go in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Engine ignition and liftoff of the Hera mission on its way to the binary asteroid system of Didymos and Dimorphous. The Falcon 9 has cleared the tower. This mission, which took 18 years to come together, now finally in flight, the beginning of a 2-year journey out to the asteroid Dimorphous. Now more than 30 seconds into flight. Now a little more than a minute into launch. Falcon 9 first stage booster is throttling down as it approaches max Q, the point of max dynamic pressure on the vehicle. Here you see the call on your screen for max Q. A couple of events are coming up in the next minute here. We'll see first stage main engine cutoff at about T plus 2 minutes and 41 seconds. A few seconds after that will be stage separation. The second stage Merlin vacuum engine will ignite about T plus 2 minutes and 51 seconds. Then the payload fairings will separate T plus 3 minutes, 33 seconds. Now 2 minutes into flight. Heard the call for MVAC chill down. They are thermally conditioning the Merlin vacuum engine prior to separation and the ignition of that upper stage. This camera view, of course, looking down at the base of the Falcon 9 first stage booster as that first burn continues on. This camera mounted to the Falcon 9's inner stage. We're approaching first stage main engine cutoff again in about 10 seconds from the point of view of the SpaceX onboard cameras and the feed that we're getting here from SpaceX. You can see that Merlin engine on your right. A good stage separation here. And that Merlin vacuum engine is now coming to life. As you can see, the first stage falling away. That first stage B1061 making its final flight after now 23 missions that it has kicked off. We're coming up on fairing separation in just about 10 seconds from now. You can see the Hera spacecraft nestled inside the payload fairings. And Hera now exposed to the vacuum of space for the first time. You can see the fairing falling away just to the left of the engine nozzle. According to SpaceX, one of these fairing halves just completed its 13th flight, the other its 19th. Could call for a nominal trajectory of the upper stage. Those fairing halves will splash down in the Atlantic Ocean under the support of parachutes. SpaceX reports all still nominal with the upper stage flight. Call that the flight termination system has been safed. No longer needed at this stage in flight. Now a little more than 5 minutes into this mission, we're coming up on second stage engine cutoff in a little more than 2 minutes. That's coming up at about T plus 7 minutes and 39 seconds. The upper stage then will continue on in a coast phase until T plus 52 minutes, 22 seconds. There'll be a second burn of the upper stage engine, which will last a little more than a minute and a half, setting up the Hera spacecraft to be deployed at T plus 1 hour, 16 minutes, and 2 seconds. Good call. Still following a nominal trajectory on the upper stage. Now T plus 6 minutes, 22 seconds in real time, 6 minutes, 13 seconds on the SpaceX feed. We'll be seeing the events, obviously, based off of the timeline of events at the bottom center of your screen, since we are relying on the SpaceX onboard cameras at this point in flight. So we're looking for a second stage engine cutoff now just about a minute away. So far, a nominal flight for this Falcon 9 rocket. As we're coming upon SECO 1, we'll note this is the 94th Falcon 9 launch of the year, the 95th for the Falcon family of rockets, since we also had one Falcon Heavy launch back in June. And we're looking for one more this year. That, of course, is the important Europa Clipper launch. Looking for a new launch date having to stand down until after Hurricane Milton is well on its way and beyond Florida. Good call for Seco 1. The Merlin vacuum engine has concluded its first burn. And again, we'll go into a coast phase now. Good call for nominal parking orbit insertion as well. Taking a look now inside the control room at SpaceX's headquarters in Hawthorne, California. This coast in total will last about 45 minutes. You can see the Hera spacecraft with a nice view of Earth on the far left-hand side of your screen. Back at the Merlin vacuum engine, there will be periodic loss of signal, and we'll go to the telemetry views here. But of course, since this is a very important customer mission, SpaceX is going to continue providing telemetry as well as views when available of the Falcon 9 upper stage, as you see here, now live. And some nice views of Hera with one of the solar panels that you can see there on the bottom of the spacecraft from this orientation. The Hera spacecraft has a pair of solar arrays that will extend from the body of the spacecraft once it's deployed from the Falcon 9 upper stage. As we continue to track the progress of the vehicle, first off, I want to thank the more than 10,000 of you who are still sticking with us. As we continue to track the mission, I want to thank a few folks in the live chat for supporting us this morning. Our thanks to Steve Martin, joining us at the pad leader level of channel membership. Welcome aboard, Steve. We're glad to have you with us. Also want to thank Tobe Wobe for gifting 5 Spaceflight Now memberships, and to Steve Frazier for gifting 1 as well. So to our newest 6 channel members, welcome aboard. We're glad to have you with us as well. Be sure to thank Tobe and Steven in the live chat if you haven't already. One of our wonderful channel members, Patty Chichil, with a $2 super chat, saying everyone in Milton's path, sending prayers and hopes to stay safe. And a thank you as well to another channel member, Chuck Close, for our very generous $25 super chat. Really appreciate that, Chuck. Thanks for supporting us here at Spaceflight Now at that level. Did see a comment from Callistia that there was a bit of an echo. Go ahead and let us know in the live chat, if you will, if you're still hearing some kind of echo, and we'll see if we can get that addressed. We're not detecting it on our end, so just keep us posted, if you will. I'm seeing a lot of no's, so Callistia, maybe just double check that you don't have this feed open twice in 2 different windows on a maybe slight lag. Copy all in the live chat. Thank you. Now T plus 13 minutes 20 seconds on the feed for which we will get the latest from the mission now. I want to go ahead and walk you back through the animation here from the European Space Agency of the flight path of Hera. We're right here on the mission, as you can see, of course, anticipating that moment of separation where the Hera spacecraft will be deployed and its adventure will begin, if you will. Following a period of checkouts, spacecraft will depart Earth orbit and begin to make its way out to Mars for a Mars flyby operation. While it's out there, it will perform a little bit of science and make an observation of one of the moons of Mars before it continues on to link up with the binary asteroid system of Didymos and Dimorphous. Once it's there, its mission will last about 6 months nominally. Walking back here is the timeline, again, with sort of a celestial overview, if you will. First deep space maneuver coming up next month, following Escape from Earth system later this month. You can see it's that yellow dot making its way out for the Mars flyby, coming up in March of next year. Then we'll continue on to begin to approach Didymos, making its second deep space maneuver in February of 2026. And finally, the big rendezvous coming up in October of that year. For those who were not with us earlier in the broadcast when we shared with you part of our interview with Mikhail Kupers, the project scientist for the Hera mission from ESA. We talked a little bit about the need for the Mars flyby and the opportunity for some science that will take place while there. So once again, here's part of our conversation with Mikhail Kupers, the project scientist for Hera with the European Space Agency.
Yes, I mean the highlight of the cruise phase is the Mars flyby. So the Mars swingby to get to Didymos, where Mars will be used for calibration, but we also will arrange for a close flyby of Deimos, one of the moons of Mars, and there we will get it from the not Mars-facing side, which is not very much explored so far. So we also hope some scientific insight from that.
Now currently T plus 20 minutes, 52 seconds and counting in real time, 20 minutes, 43 seconds on the SpaceX feed. In part of our conversation with the project manager for ESA on the Hera mission, that of course being Ian Carnelli, we talked about what will happen when the spacecraft separates from the Falcon 9 upper stage and the pathway out towards the binary asteroid system of Didymos and its little companion Dimorphous. So in this part of the conversation, we delve into all of those events, what's about to happen in less than an hour from now, and the journey out from there.
After separation, we go into auto sequence. So there's a deployment of the solar arrays. That's the very first critical part. And then a lot of, let's say, automated sequences on the spacecraft, up to the point, as you say, where we acquire a signal that's expected to be about an hour and a half after launch. So that's when we expect to get the signal. And then from that moment on is 2 days of wild horse ride. So all of the Hera project team is now, actually as we speak, they are in the control center in Darmstadt in Germany. Mm-hmm. They're doing their final simulation campaign. So we have 2 teams working through 12-hour shifts, and blue and green team, and they will be taking care of the baby and going through all of the procedures to put the spacecraft to be able to do the first maneuver. I think it's like 4 days after launch, which is super fast for us. Normally we like to take it a bit more easy, and that's also when we'll be taking our first picture with our main payload, looking back at the Earth and the Moon. And then we have our first deep space maneuver 2 weeks after launch, and then we'll be heading to Mars. And recently we agreed to use a bit more propellant for the Mars flyby, to allow our scientists to observe Deimos, Mars moon Deimos, because we have a hyperspectral instrument that has never been used to observe Deimos, and there's a nice geometry there that allows them to do apparently some very interesting scientific observations for Mars. And then after that, 2 years of cruise until we reach Didymos in 2016. What is kind of funny is that the mission has been built in such a short time that we haven't defined yet the close proximity operations. And this is something that most people don't realize. So we are launching having, let's say, a good baseline, but not all the details worked out of what we will be doing once we get to the asteroid. And we'll be using the 2 years of cruise to nail down day by day what we're going to do. So right now we have a reference plan. We know more or less where we'll be deploying the CubeSats, more or less in which time frame, but nothing really specific.
So how soon or how much time before you arrive do you need to kind of button that up?
Oh, we'll be doing that at least, a graceful 2-3 months before we arrive. Oh, that's plenty of time. Of course. But that's totally the Hera spirit. Yeah.
And that's sort of been the kind of mission that Hera has been. They've gone through lots of trials and tribulations to get this mission going. Of course, in its original iteration, there was a mission from the European Space Agency called Don Quixote, which was imagined back in the 2004 time frame, which essentially pictured the pieces of both DART and Hera, but lumped into a singular mission. It was reimagined and split into DART and then what was previously called the AIM mission from the European Space Agency, which AIM would have launched before DART, would have been present for the collision of the DART spacecraft against Dimorphous. However, the 2016 ministerial, in which the ESA member states decide the funding and path forward for future missions, decided to not go ahead and fully fund the AIM mission, and there wasn't really enough potential funding to continue with it as it was. So there was a lot of retooling that had to happen, and they came back and got full funding in 2019, at which point they had really gotten everything buttoned up. They had the 2 CubeSats that were set to ride alongside the Hera spacecraft, and then they were off to the races. At that point, once they got full funding, they were able to keep within their funding limits, not go over budget, not go over time, and they made it right here, where we saw an on-time liftoff right at the opening of this planetary launch window, just in the nick of time, of course, before Hurricane Milton goes ahead and makes landfall here in the Sunshine State. Currently T plus 27 minutes, 13 seconds and counting. Again, the next milestone we're looking for here is coming up at T plus 52 minutes and 22 seconds. That will be the second burn of the Merlin vacuum engine, lasting a little more than 1.5 minutes in duration. And that will set up the Hera spacecraft to be deployed at T plus 1 hour, 16 minutes and 2 seconds. Currently T plus 41 minutes, 42 seconds on the SpaceX feed. We are now just about 10 minutes away from the second burn of the upper stage engine. That Merlin vacuum engine will ignite and burn for a little more than a minute and a half. And that'll position the upper stage of the Falcon 9 to be able to deploy the Hera spacecraft coming up, T plus 1 hour, 16 minutes, and 2 seconds, to begin its 2-year journey out to the binary asteroid system of Didymos and Dimorphous. For those tracking the weather, and of course all of us here in the central Florida area are very much tracking the weather, according to the National Hurricane Center, Hurricane Milton is now, as I'll quote them here, continuing to rapidly intensify, forecast to become a Category 5 hurricane. So it's just a thought to all of our viewers who are in the potential path of the storm. If you haven't already begun to make your storm preparations, now is the time to do so. Don't hesitate. Be sure to listen to local advisories as far as any evacuation advisories, especially for those who are in central Florida and out to the west, those along the Gulf side of the state. We'll be thinking about you over the next few days as Hurricane Milton makes its way towards Florida. Of course, the approaching hurricane is the reason why NASA's Europa Clipper mission, which was scheduled to launch originally on October 10th, the beginning of its planetary window, that mission now pushed off to some point in the future, potentially no earlier than this weekend. Again, assuming all goes as smoothly as possible as far as the impacts of the hurricane here at the Kennedy Space Center. Clipper spacecraft is safely nestled inside the hangar at Launch Complex 39A, as are the cores of the Falcon Heavy boost, or the Falcon Heavy rocket. All that being said, on the weather front, we're also waiting to hear from the Federal Aviation Administration, or the FAA, here in the United States, as to whether the Falcon Heavy is in fact cleared for that launch when the weather is good to do so. SpaceX, according to the FAA, did submit their post-mishap investigation report and a request to return to regular flight operations on Friday, October 4th. So far, the FAA cleared SpaceX to launch just this mission because of the unique circumstances for the upper stage. The fact that it would not be coming back and splashing down in the ocean using a deorbit burn. Neither will Europa Clipper, for that matter, so in all probability, given A, that fact, and B, the timing needed to launch this mission, the fact that the Clipper mission, like Hera, has a finite planetary window. Clipper lasts until November 6th, so they still have, I'll say, a decent amount of time, but you never want to burn the margins while you have them available, if, at all possible. Now T plus 47 minutes, 5 seconds and counting. Taking a look at the live chat, want to thank a couple more folks for their support this now late morning. Our thanks to Buster Rex for a 10 Australian dollar super chat. Appreciate that, Buster. Buster says, do such a great job at explaining what's happening and provide good and interesting commentary. Thank you for what you do. Appreciate those kind words, Buster, and also your support of. I'll expand the compliments to the team here at Spaceflight now, since this is very much not a solo operation. Although I'm the one on the mic, there's, of course, a great team of folks behind the scenes that help make these live launch broadcasts possible. But thank you for the words. Also want to thank Callistia Lee for gifting 10 Spaceflight Now memberships. Really appreciate that, Callistia. And to our newest 10 channel members, welcome aboard. We're glad to have you with us. Be sure to thank Callistia in the live chat if you haven't already. Now T plus 48 minutes, 19 seconds and counting, just about 4 minutes away from the second and final pre-deployment burn of the upper stage. As we're awaiting that, want to go ahead and take a look back on the moment of launch as captured by some of the aforementioned folks who are not currently on the mic. This trio of camera views, the first two coordinated by our Adam Bernstein here at the press site, and the last one from our friends Chuck and Jen Briggs with C&J Images. So again, you're watching a launch replay of the Hera mission as it took off from Space Launch Complex 40 at Cape Canaveral Space Force Station at exactly 10:52 a.m. Eastern this morning. 14:52 UTC for folks joining around the world. Of course, not the absolutely most picturesque launch, as it did disappear into the clouds fairly quickly, as you can see in this launch replay. But the most important thing for the European Space Agency, of course, is that Hera very much is now on its way, getting ready to sail on its own power coming up later this morning. This is a look from our wide camera here at the press site. And from this vantage point, it will sail off screen on into the clouds, and then we'll turn to the view from Chuck and Jen Briggs over at Cape Canaveral Space Force Station. So you can see the water deluge system kicking on there before the 9 Merlin 1D engines roar to life, and then the Falcon 9 takes flight. Again, those payload fairings that you see at the top of the rocket flying one half for a 13th time, another half for a 19th time. The booster, of course, B-1061 making its final flight on mission number 23, sailing into the history books for SpaceX. The company is looking to certify both its boosters and its payload fairings to support up to 40 flights each. We're now T plus 50 minutes, 55 seconds and counting on the SpaceX feed, just a little less than 2 minutes away now from that upper stage second burn. we're now coming up on that second burn. Let's go ahead and listen in here.
Ignition.
And right on time, SES-2. That call out was for second stage engine start. Now this burn is planned to last about a minute and a half. And we got a great view of that MVAC engine burning very bright there. Now during this time, we will be adding 4,500 kilometers per second to our velocity. And again, on the bottom right hand of your screen, you can see the speed increasing rapidly there, and you can also see the altitude of the vehicle and the payload. Now this is the second burn for this mission. There are 2 planned burns for this payload to be dropped into an interplanetary orbit. So that first burn took us into an Earth orbit, and now this second burn that's currently happening right now is taking the vehicle and the payload to that interplanetary orbit where the Hera spacecraft will be deployed. Now we're just about 30 seconds away from the conclusion of SES-2, which will be SECO-2, that second stage engine cutoff 2. And then we will shut down that MVAC engine, allow the vehicle to coast for a little bit prior to the deployment of the payload. Now SECO-2 is coming up here in just a few seconds.
MVAC shutdown.
We did have SECO-2, just waiting for confirmation of a good orbit. There you can see on your screen the MVAC engine has shut down. And the Hera payload there on your screen still attached to Falcon 9. If you're just now joining us, we did have 2 completed burns for that MVAC engine. Just about a minute ago, we had SECO-2 where that second stage engine did cut off, and you can see that there, no longer firing. And we do still have the Hera payload still attached to Falcon 9.
Officer call out a good burn. I think they may have been stepped on. We're looking at the data and we've heard the background chatter. We do have confirmation.
Nominal burn 2.
There we
Good
go.
orbit.
The chief engineer has confirmed we have a good second burn of the MVAC engine. So that means the Falcon 9 second stage, with the Hera payload still attached, has escaped Earth velocity. So we're no longer orbiting the Earth, we're now orbiting the sun. We've got one more major activity remaining in this launch mission, and that's the spacecraft deployment. You can see the Hera spacecraft right there, still attached to Falcon 9 second stage. That's expected to occur at T plus 1 hour and 16 minutes. So we've still got another 20 minutes, which means we're going to take a short break. And we'll see you back here at T plus 1 hour and 15 minutes for spacecraft deployment.
Now currently T plus 1 hour, 6 minutes, 45 seconds in real time. 1 hour, 6 minutes, 36 seconds on the SpaceX feed. We are coming up on the final 10 minutes of the mission from SpaceX's involvement. The deployment of the Hera spacecraft is set to come up at about T plus 1 hour, 16 minutes, and 2 seconds. Now currently T plus 1 hour, 9 minutes, 38 seconds and counting. Taking a look at our split screen here, of course, to the left is the ongoing telemetry data from the Falcon 9 upper stage, tracking the progress of the European Space Agency's Hera mission. That spacecraft set to deploy now less than 7 minutes. On the right-hand side of your screen, you're looking at the countdown clock. Just beyond the countdown clock, of course, is Launch Complex 39A, where the Europa Clipper spacecraft is waiting for its turn to launch atop a Falcon Heavy rocket. That mission originally scheduled to lift off at the beginning of its planetary launch window on October 10th. But of course, we are now facing down a currently Category 4, expected to become a Category 5 strength hurricane. Hurricane Milton, making a beeline straight for the Tampa and Central Florida area at the moment. Still gaining in strength. And so NASA will pivot to another opportunity on the other side of the hurricane and provide an update on the launch availability once an assessment of any potential damage to the Kennedy Space Center is taken stock of, once it is safe to do so. taking a look at the live chat, I want to thank Ramraj MGV for super chat. Really appreciate it. We're 5 minutes past the hour here on the East Coast, just a few minutes away from the deployment of the Hera spacecraft as the rain's starting to pick up here. The Kennedy Space Center, released out at Pad 39A, starting to make its way out here to us in the next little bit. Do want to make a note that as of the 11:55 up Eastern Time update from the National Hurricane Center, Hurricane Milton has officially strengthened to a Category 5 hurricane. The report, and I quote, "The maximum sustained winds are estimated to be 160 miles per hour or 250 kilometers per hour with higher gusts. Data from the aircraft also indicate that the minimum pressure has fallen to 925 millibars or 27.31 inches. Current location, 21.7 degrees north, 91.6 degrees west." The inclement weather that we've been experiencing and continue to experience here at the Cape was forecast ahead of the formation of Hurricane Milton and is not directly related to it. Of course, we'll start to see the impact of the storm over the coming days this week. Currently, the storm is about 735 miles or 1,175 kilometers southwest of Tampa, Florida. Again, just as a reminder to all those who are in the line of the storm's projected impacts, now is the time to make your hurricane preparations, and of course, if you get local advisories, to evacuate. Local advisory. We're now within a minute of the deployment of Hera, so let's go ahead and listen back in to John Innsbrucker from SpaceX.
Stage separation, we've had the 2 burns of the second stage engine. We've got one more major milestone coming up to complete today's mission, which of course is the deployment of the Hera spacecraft from Falcon 9's second stage. That's going to happen just over 30 seconds from now. And you may have noticed when we shut down the engine at the end of the second burn, we were 204 kilometers, a little more than 120 miles above the Earth. If you look at the display on the bottom right of your screen, we've just crossed 7,400 kilometers as we continue to head out into deep space as we have exceeded the velocity to escape from Earth. But right now, let's listen to hear the call out and watch for separation of Hera from the second stage.
Hera separation confirmed.
Great view. We've got successful deployment of the Hera spacecraft.
And with successful payload deploy, that brings our webcast to a close. Today's mission marks SpaceX's 389th overall mission to date and 94th mission of this year. Thank you to the European Space Agency for entrusting us with today's mission, as well as the range for their support. For continuing coverage of the mission, check out @ESA on X.
And with that, we are going to go ahead and wind down our coverage as well of the Hera mission. Really appreciate all of you who have stuck around to the end. Want to go ahead and wrap things up as we usually do with a look at the mission stats as they currently stand. This, as we mentioned, marked the 23rd and final flight of Falcon 9 booster B1061. This was the 379th Falcon 9 launch to date, the 94th of this year. This was the 322nd Falcon booster reflight, or the launch of a booster that has flown at least once. This is SpaceX's 98th launch of the year, including a Falcon Heavy rocket. And a couple of launches of the Starship vehicle. Typo should be 97th, excuse me. This is their 120th orbital launch within the last 365 days. This was also the 208th orbital launch from Pad 40 and the 263rd overall orbital launch from this particular pad. Because the booster was not recovered, we'll go ahead and skip the recovery stats. So here's a look at where the bar chart stands right now for their Falcon launches on the year. We're going to go ahead and come back to the recovery stats in just a second. Let's go ahead and listen to the ESA broadcast for just a moment here. Taking a live look right now into the ESOC there. The operations control room in Europe as they're looking for acquisition of signal from the Hera spacecraft. Important moment in the mission when folks
acquisition of signal over Goldstone.
We have just heard the Flight Director Ignacio Tanco confirming successful signal acquisition. This is the best news of the day.
You can see the Director General of the European Space Agency, Joseph Arschbacher, on the right, and the blue suit jacket and the black glasses. I think we'll be hearing some words from him in just a moment. Looks like some members of the Hera operations management team are gathering, and we should be hearing some comments, it appears. In just a few moments, so we're going to go ahead and continue listening in. So we're expecting to hear some words from hardworking folks in the ESOC now that signal has been acquired with the Hera spacecraft.
Just one, I see rather inconsistent readings on the solar cells. I see only one with good voltage, say 1, 2 and 3.
The other stations, so beyond the briefing loop, we confirm acquisition of signal. We are now asserting control over the spacecraft, and mission operations is ready to start operations of the Hera mission.
Okay. So what an incredible day. It's just what we've witnessed, the successful launch of the Hera mission, seen the spacecraft separate in an absolutely beautiful view. We've seen that amazing...
We're going to go ahead and peel away from now. Did hear some background chatter that there may have been some inconsistency with the solar cells on the Hera spacecraft, so we'll look for some additional updates from ESA if that's creating any kind of impact on the Hera spacecraft. But so far, the mission has been largely successful. They did get a good acquisition of signal with the spacecraft. Again, we'll put a pin in the potential hiccup with the we heard as inconsistent reading from the solar cells. May just be an initial assessment that can be cleared up as they continue their checkouts over the next hour, several hours and few days. Closing out with the conclusion of our mission stats here. This marked the 68th orbital launch from Florida this year, the 102nd from U.S. soil, the 112th from a U.S. rocket company, the 183rd orbital launch from around the world. There have been 6 orbital launch failures so far. Here's where the pie chart currently stands. And for those tracking activity on the suborbital front, the new Shepard 27 mission from Blue Origin is aiming to launch today. This is a non-crewed flight that, as of the last few minutes, appears to have been in a hold. So you can go over to the Blue Origin page and check that out. We certainly appreciate all of you who have been here throughout the course of our live coverage. If you're not already, be sure to subscribe to Spaceflight Now here on the YouTube channel. I want to thank our folks who have been supporting the coverage. Our thanks to Pete Carsons with Max Q Productions, to Chuck and Jen Briggs with C&J Images, to our photographer Adam Bernstein, who is busily bringing all the cameras indoors to safeguard them from the incoming rain. And we're going to take our necessary precautions here to make sure that all of our stuff is safe from the impacts of Hurricane Milton over the next couple of hours. So we'll be quite busy for the rest of this afternoon, but want to thank our wonderful channel member community for your ongoing support, and to our moderator, Callisti Lee, for helping us out in the live chat today. Most importantly, want to thank you at home for watching and supporting what we do here at Spaceflight Now. And before I leave him off the list, our thanks is, of course, as well to our Spaceflight Now editor, Stephen Young. For all of us here at Spaceflight Now, I'm Will Robinson Smith. Be good to yourselves, be good to others. Heed the local warnings for those who are in the path of the hurricane. Stay safe. And folks, we will see you next time. And until then, bye-bye.